Question 6.1, we are given p of x being equals to minus 3x squared. And 6.1.1, we are asked to give reason why the inverse of p is not a function. So our p of x is equals to minus 3x squared, right? So if we were to draw this function here, it's going to look like this. Because our a value is negative, so it means now that our function will face down. This is a parabola, by the way, so it's going to face down like that. So this is p of x. The inverse of this parabola will look like that, right? So the reason why this inverse of p is not a function is because if you are going to use a vertical line test and test all these values here, you will find that the vertical lines touch the graph twice, at this point and at this point, this point and this point, this point and this point. So the fact that the vertical line test touches the graph at 2 points, it makes the inverse not a function. So you can simply say p of to the power minus 1. So the inverse of p fails the vertical line test. Now 6.1.2, we are asked to place the restrictions of the domain of p so that it becomes a function. So remember that we said the inverse of p is not a function, right? So we want to make it a function now. How do we do that? We place our restrictions. So let's first draw our graphs. I'm just going to draw 2 graphs here. So when your p of x looks like this, right? And if you draw the inverse, it's going to look like that. So this is the inverse of p, and this is p, right? P of x. So for us to really place restrictions for this here, we need to eliminate a portion of the graph. So this is what we're going to do. We're going to draw just one part. So if we say we eliminate, it means now that if I consider only this portion of the graph, the other portion I don't consider. So if I consider it, so I'm going to write it here. So I consider this portion. So what does that mean? I restricted my graph to x being greater or equal to 0. So my x values start from the origin all the way to positive infinity, right? So I've restricted the graph. So now, how will my inverse look now that I've restricted my graph? So it means now that we're only going to consider this portion now of the inverse, right? So meaning that my graph is going to look like this. So it's going to have the inverse looking like this. So that is going to be my portion of the inverse, and this is going to be my p of x, right? So this is how I restricted my graph into x being greater or equal to 0. So that's what you need to write. Or I can restrict my graph to x being less than or equal to 0. So how does that look? You draw your graph like this, and now we're going to look at this portion here, because it's less than or equals to 0, right? So if we look at that portion, we need to draw it. So we're going to look at this portion of p of x, and now that we look at this portion, how will my inverse look? So means now that we're going to consider this portion of the inverse, this one here. We're going to consider this portion of the inverse. So now we're going to draw it. So it's going to look like this. So now we have restricted my p of x into this point. So that's how we do the restriction of our functions. In 6.2, we are told that in a test, Peter was required to determine the derivative of f, right? But he made a mistake and found the inverse of f, which is this one here. So we need to correct Peter. As it says, determine the correct answer given in a test. So we need to correct Peter by finding the derivative, not the inverse. So the inverse that Peter found was the root of x over 2, right? So we need to correct him. So what you need to do is we're going to square both sides. We know that this is the inverse, which you can write as y, so which means we square it and we square the x over 2. So we're gonna have y squared is equals to x over 2. Then since it's an inverse, we have to swap. So where there's x, you put y, where there's y, you put x. So which means here it's going to be x squared is equals to y over 2. Then we cross multiply. So it's going to be 2x squared is equals to y, right? So now we derive this. How do we derive y is equals to 2x squared? So we derive, it's going to be 4x. So this is the derivative that is required.